In addition to constructing composite functions, we can also evaluate them, which really isn't any different than evaluating functions like we've done in the past. We just need to make sure we're paying close attention to the name that we're calling on so that we're plugging our value into the correct function. In example 3, we want to refer back to the expressions, the functions that we had in example 1. First, we want to evaluate f of 1, which means we'll take our function f and evaluate it when x is equal to 1 to get 7. In part B, now we want to evaluate g of 1, meaning we need to look at that function g and evaluate it when x is equal to 1. Which in this case gives us 9. In part C and D, we've already constructed those two composite functions. Again, the important thing is just making sure we're paying attention to the naming convention so that we're referencing the correct function. If what we want is f of g, then we're using that first function, that first composite function that we constructed. So this will be 10 times 1 squared plus 8 times 1 plus 5, which will give us 23. And then in part D, we'll look at g of f of 1. So we'll take that second composite function that we constructed, 20 times 1 squared plus 108 times 1 plus 145 will give us 273. Again, notice that we come up with different values for f of g of 1 and g of f of 1. Since those two functions are different, we should come up with, or we're likely to come up with different values. But we could have instances where those two values come out to be the same as well. In example 4, we want to repeat this, but now with the functions from example 2. Paying close attention to the function that we're calling on so we know what to evaluate. If we want to evaluate m of 0, we would plug in x equals 0 plus 3 to get 3 as a result. In part B, we'll substitute in x equals 0 into function n. That will make our first term go to 0. Plus 6 is equal to 6 as a result. When we evaluate m of n of 0, plugging in x equals 0 sends our first term to 0. Plus 9 gives us 9 as a result. And evaluating n of m of 0 turns our first 3 terms to 0. Plus 114, so a final answer of 114.